Hello, my friend. My name is Anton from economy.com, and today we would continue our discussion about gNMI. We haven't talked about our wonderful, at least we believe this is wonderful, open source Python library to manage devices with gNMI for quite a while. You might think probably we have abandoned this project. It is not that true. Actually, we was working a lot in the background, and we are genuinely thankful for everyone in the network automation community who have contributed to this project and made this project truly open source. Today, we will discuss one of the interesting features which actually was implemented by our collaborators. And I said, again, we are very thankful them to do that. So the feature is gNMI CLI. At the very beginning of our project, we were trying to avoid creating the CLI for two basic reasons. There was CLI already created, gNMI CLI with the gNMI C client created by the Nokia folks on the one hand, and we don't want to create just yet another tool. On the other hand, we also wanted to focus solely on the tool which is suitable for being used inside the Python, because we are developing the application Python for ourselves, for our clients, and these applications are being run into their automated end-to-end environment, being triggered through the API endpoints and others, and there are normally no much place for the CLI. However, we have got few requirements or few asks from all of you, our dear watchers, our dear followers, and we decided, okay, if there is a demand, we'll provide the supply. So what is gNMI CLI? The best way to explain what gNMI CLI is to show it to you. So let's remind ourselves how our topology is looking like so that we can get to that. You see right now the topology that we have used generally through all our sessions. We have our server where we have gNMI running. It's ordinary Debian Linux with Python 3.9 and gNMI installed. We also have two routers in our lab, which is a Nokia SRS and Arista US. We have a virtual images for them, therefore very easy for us to make the testing. However, we already got confirmation that gNMI was tested and working with Cisco ASXR, Juniper GNOS, and Nokia SL Linux. So the amount of the platform that gNMI is supported equals the amount of the platform where you could use a gNMI. So now let's get started with gNMI itself. And to start testing, let's jump to the CLI, to our server running gNMI. Let me share a different screen where you would see this CLI. So the good thing about the gNMI, you don't have to install it separately. As long as you install the gNMI via the PAP, as you usually do, the gNMI CLI is available for you immediately. Let's do this installation, PAP install gNMI. It is downloading the latest version of the gNMI, which is to the date 0.6.6. It's constantly upgrading right now. We're adding some functionality to figure out that some keys from the gNMI specification were missing. On the other hand, those keys were not that important. On the other hand, we want to implement this specification as detailed as possible, and therefore the library is right now on the constant upgrade. gNMI is almost installed, at least as far as I could see. Yes, and we could start using the gNMI CLI. So first, as you see, you type just gNMI CLI in the command line, and immediately you see it's auto. The command is basically in there. Let's ask for the help. So for those who have previously seen any tools like Ansible or any others, you know that they have a very vast help, and this is what the gNMI CLI has as well. It provides, in the case with the help of the details of all the commands and keys that you can use. You could use a short version of the key, because you could use a long versions of the keys. Let's take a look what those keys are. Obviously, there are a few mandatory keys such as target and username, which you need to provide to the basically the host which you would like to connect to. You could use IPv4, IPv6, or FQDNs at the host name and the port, because they are port on the different platforms is different. For example, on the Arista, the default gNMI port is 6030 TCP. For the Nokia, it's 57400. For the Juniper, there's no default port at all, and you need to configure them. Then Username as well is mandatory. The password, if you are comfortable to pass your password as a key, you could use -p. If you are not, don't worry, you'll be asked by the pygnmi CLI to provide your password at the point when you are connected. You see a number of keys which are talking about the certificates. The pygnmi CLI supports both secure or encrypted gRPC tunnel and insecure, basically unencrypted gRPC tunnel, which would allow you to implement both types of connectivity. Obviously, insecure is suitable for the lab, whereas secure is mandatory to have in their production. You could use also the right functionality, which is helpful when you work with a self-signed certificate. Otherwise, your validation will be passed. Some other key to basically create these insecure channels and others and others. So let's see how it is working. First of all, we right now would try to connect to the device which does not have secure channel. So we'll be using the insecure flag. How we're using them, typing pygnmi CLI, then we're providing the target IP address of our host and the port, so 6030, which means we're connecting to the Arista router. Then our username. We would also specify that we would like to use insecure channel, so -i, and our operation will be simple capabilities. You asked about the password, providing the password, and you see the output in the JSON format. So this is already converted data. This data allows you to see what the device supports in terms of the supported models, in terms of their, and with this, you see their name of the YARN model, organization who has created version of the model. Then in the end, you have the encodings in gNMI version. We have discussed this all before when we were using the pygnmi as a part of the Python script. Now, what we will do right now, if you are not interested into the, or if you are more interested into learning the protobuf structure, because the output is of the JSON, this is what pygnmi is doing for you. It's converting the protocol buffers encoding to the native Python data models. You could take a look also in the native protobuf. To do that, you add just a key -d or debug. Once you provide the key, you see what is the request, and the reason why the request is empty, because generally capabilities request is empty, doesn't contain any data. You see the response yet in the protocol buffer encoding, not decoded. But again, you could navigate and understand how the protocol buffer itself is looking like. Now, let's add the encrypted functionality. So I have the key cert them. So I have downloaded upfront from the Arista, the self-signed certificate, which is mandatory for this to work. Might also see that the folder log has appeared. Let's quickly take a look what we have inside. So it is storing the output of your execution. So you'd see what was successful, what was not. So storing all the details about the execution of the application itself. Now, let's take a look how the encrypted channel would work. To do that, I need to go to Arista device that we are using right now and enable the certificate, which is taking me just a moment. So this is done. Now, if I would like to connect using the same approach without the certificate, right now I would have a failure because now Arista require me to have certificate. You see the tracebacks. Let's take a look in our execution log. You see now it was not successful. Good. So what we need to do right now, we basically now need in our certificate, in our pygnmi call, instead of calling insecure channel, we need to use a key C or pass cert and specify the certificate that we are going to use. We also need to specify the override functionality, because our host name is, when we create this self-signed certificate, we create it for a certain host name. And this host name needs to match to pass the validation. So we are using their override functionality. Now, as you see, the connectivity is successfully established, and we have the data collected. So encrypted channel with override functionality. If you have deployed the FPDN and proper PKI, you don't need to use override. When we deal with the lab, there is also another trick what we can do to avoid or to simplify the validation. We can add their corresponding host name to their hosts file. So you see we have added their IP address and their host name to our host. As we have this entry added, we now can connect to their device using FPDN. And as we are connecting to the device using the host name, I could remove this override key and connect to the device using their host name. In this case, certificate validation will be successful. And you see all the information is collected. Now, this was just about the capabilities request. The gNMI CLI implements everything that you have available in the gNMI because it relies on the pygnmi, and all the capabilities that pygnmi have is available for the pygnmi CLI as well. So let's do some information collection using the GET request. So how we will do this? We specify that our request is GET. When we specify in the GET request, we need to provide the path, the X path, which will be converted by the pygnmi library into their gNMI structured protocol buffer encoded path. So let's provide, we'd like to collect the information about, for example, open config interfaces. It's the name of our model, interfaces. Let's take a look. Looks like okay. So as you see, we are receiving in the structured parsed format what exactly we have in this message back. Again, if you're interested in take a look at the protocol buffers, you could use -d. Then you see in this case request, what was in gNMI request, what was in the response. You could see that in case of the gNMI, how it is implemented in the Arista router, it's actually implemented in all vendors. Cisco, IS, XR the same, Juniper General is the same, Nokia SRA is the same. We have a key JSON file, JSON IETF file, which is contained in the JSON format, just in the string encoded, the contents of all the materials. The rest of the structure, as you see, is protocol buffer. So obviously it's a little bit difficult to read this content, and that is the reason why, without using the cached, you could rely on the functionality of the pygnmi itself to decode for you all the details. You could also specify if otherwise you're interested in the operational data or in the config data. This is there for you. Okay, so now let's take a look how set is working. Basically, we can also implement the functionality to create the new item in their device using pygnmi CLI. So first, let's try to collect the information, for example, about interface, specific one, name, loopback 61. We don't have this interface, and therefore, as you see, we are receiving the empty prefix back. I could probably even delete cached KD. So nothing is received back. Okay, so now let's create a test file. So why we need to have a file? If you take a look in the pygnmi CLI, we would see that it's possible to read the configuration from the file. Basically, the content of the file together with XPath would allow you to push the configuration to the device. So let's create such file. So we'll create it following the Young model of the open config for interfaces. We'll create a new interface. Let's say it will be called loopback 61. Then we create a new config key, again following the open config model. So I need to repeat the name. Then we provide the interface type for the open config. where back. Then we have description that will attach to the interface. And finally, a key to enable this interface. Okay, so the interface should be now, the JSON file should be now ready. I believe it is. Okay, so tell that probably something is, you can see right now, it should be okay. So, okay, good. Now, how to configure this interface? So to do that, we'll take basically the same path, but we'll use a different request type. We'll use the way how it is implemented. So we have a specific set. So from the pygnmi perspective, the call is called set. So the RPC is called set. However, it has different options. It could be update, replace, and delete. They are implemented as separate operations to simplify your understanding how it is working so that you could learn and test this. So let's say we implement set update. We are using the same XPath, and we also add the parse from the content of the file to implement the key. So specifying this. So as you see, the request is being done to the device, receiving back the information, what actually was done. And now we can take a look whether the interface is indeed created. Now you see that interface is existing. We have a path that we're willing to, that we can collect from interface. We see the description is properly set, interface type is software loopback, and interface is loopback. So as you see, we have implemented we have tested the 10 functionality with the pygnmi CLI as well. Finally, you could also rely on exactly the same approach of creating the XPath, implement the subscription. For example, there is not much activity happening on the loopback 0, but there is probably some updates happening on the interface management 1, which is a management interface to which we are connected to the device right now. Let's use the different operation. So the operation will be subscribe. And as we have discussed about the set, there are different types of subscription. In fact, in OpenConfig, in gNMI, there are 3 types of subscription. This is stream, this is pool, and one. So we'll show the stream, but you could use any others as well. So subscribe, stream, still same gNMI path or XPath being converted in the protobuf encoded gNMI path to collect this data, connected to device. And now we are waiting up and we see their response from the device. So you see what are the counters and others. This is a stream. The standard subscription is several seconds. So now you see the second batch of the telemetry. Once we are waiting till the end of this interval, so next 10 seconds, you see the information collected again and again. So you have possibility now to take a look what exactly is received. It is native Python dictionary right now. So you can understand what and how the some parameters are changing and others and others. This is how the pygnmi is looking like. This is how it could help you to explore the capabilities of your devices, what they can in the gNMI, and also it would give you possibility to use the pygnmi as a one-stop shop for your network automation with Python and gNMI. So if you like this tool, absolutely feel free to use it everywhere. We're happy if you have the questions. Raise it please with us on the GitHub or contact us in the direct messaging in LinkedIn or Twitter. If you like it, again, make sure you put the star in the GitHub for this library. We would like more people in the world know about this library and use it. And for sure, if you are willing to contribute, bring your ideas, feel free to do this again in the GitHub. Raise pull request. We have already around 30 pull requests from the contributors worldwide. Somehow processed, and people has contributed a lot to this. Join this network automation family. Thanks a lot for your attention. If you like this video, make sure you put a like in the YouTube, and take care and goodbye.